Hey guys, today we're going to talk about radian measures of angles. A radian is just another way of measuring angles, just like degrees. It's just a little different from degrees, but it really is just a way of measuring angles. A radian measure is equal to the ratio of arc length over radius. Okay. Arc length is abbreviated by S, radius by R. So radian measure is S over R. So if the length of an arc is equal to the radius, the angle measure would be 1 radian. Okay, so if arc length and radius are the same, that would be a number over itself. That's 1 radian. The unit circle has a radius of 1, which means in a true unit circle, we're always going to have a 1 in this denominator. So whatever S is over 1, that is the radian measure. So the radian measure, if the radius is 1, the radian measure is equal to whatever the arc length is. So how many radians in one complete revolution? So all the way around a circle, that's 360 degrees, but how many radians is that? So if you're going all the way around, then the arc length is the same as the circumference. The circumference is 2 pi times the radius. So S would be 2 pi r for a whole revolution over r, and those r's cancel. So 2 pi radians is 1 revolution all the way around the circle. So in other words, 2 pi and 360 are the same thing. 2 pi radians and 360 degrees are coterminal. So when I need to find a radian value on these important points on a unit circle, first I remember, if I don't go anywhere, that's 0 radians. Now I know that 2 pi is all the way around, which means halfway around is 1 pi. Okay? For what I do from there is I just count. Okay? So the most important thing we get out of this is how to count around a unit circle. So if I go to these quarter points, so I go a quarter of the way, halfway, 3/4, and then all the way around half that circle, and then these other quarter points as well. I count by 1/4. So this first spot is 1/4 pi, or pi over 4. Then 2/4 pi, or 1/2 pi, pi over 2. 3/4 pi, and 4/4 pi, which is 1 pi. Then 5/4 pi. 6/4, which is the same as 3/2. 7/4. And 8/4, which is 2 pi. Okay, so 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. For the other numbers, I count by sixths. So this is 1/6. 2/6, and 2/6 is 1/3. 3/6, which is 1/2. 4/6, which is 2/3. 5/6, and 6/6, which is 1. 7/6, 8/6, which is 4/3. 9/6, or 3/2. 10/6, which is 5/3. 11/6, and 12/6, which is 2. So instead of memorizing these numbers around a unit circle, what I want you to do is just be able to count your way around the unit circle. That's what you can do to remember a unit circle when you just don't remember the unit circle. Okay, so I'm actually going to get rid of all of those. And I'm going to locate all of these points on the unit circle just by counting. 7 pi over 6, 1, 2, 3, 4, 5, 6 sixths, and 7 sixths is right here. 7 thirds. We haven't really counted by thirds, but that's the same as 14 sixths. Now remember, halfway around is 1, so that's 6 sixths. All the way around is 2, so that's 12 sixths. 13 sixths, 14 sixths. So there's 7 pi over 3. Okay, then we're going to count by fourths. So 7 fourths, 1 fourth, 2 fourths, 3 fourths, 4 fourths, which is 1, 5 fourths, 6 fourths, 7 fourths. 7 fourths is 1 short of going all the way around, which would have been 8 fourths. So we could have just gone all the way, and that's 8 fourths, back up 1 fourth, and we're at 7 fourths. And then 12 pi. Now this time I can just go halfway around, and I'm at 1, then 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. We should see a pattern. Odd pi, even pi. So 12 pi is going to be right there. Go ahead and pause the video and try to locate all of these on this circle. So 4 pi over 3, we haven't counted by thirds, so we'll make that sixths. That's 8 pi over 6. Okay, so if I go halfway, I'm at 1 pi, which is 6 sixths, 7 sixths, 8 sixths, right here. So that is 4 pi over 3. 11 sixths, I'm already at 8, 9, 10, 11. 11 pi over 6. Or I could have started from here and counted to 11, or start here. All the way around is 12 sixths, because that's 2. Back up 1 to get to 11 sixths. 9 fourths. If I go all the way around, that's 8 fourths, because that's 2. I only need 1 more fourth. 9 fourths is right there. -7. Now that negative means go counterclockwise. I'm sorry, it means go clockwise. Positive is counterclockwise, negative is clockwise. -1, -2, 3, 4, 5. We should see a pattern. Odds are over here, evens are over here. So this is -7 pi. 5 pi over 6. So we're counting by sixths. Now if I go halfway around, that's 6 sixths, because that is 1. Back up 1 more, and I'm back to 5 pi over 6. And 7 pi over 2, that's the same as 14 pi over 4, so we need 14 fourths. If I go all the way around, that's 8 fourths. 9, 10, 11, 12, 13, and 14 fourths puts me right here, so that is 7 pi over 2. All right, now, converting between degrees and radians. When I have degrees, but I want to convert to radians, what I need to do is multiply by pi over 180. So we're bringing in pi, and we're canceling out 180. Okay, so 120 pi over 180. And I can use my calculator, or I can simplify these myself. Either way. 120 over 180 simplifies to 2/3, so it's 2 pi over 3 radians. Okay, so go ahead and pause the video and try this next one. So what you need to do is times pi over 180, so 450 times pi over 180. So that's 450 pi over 180. And you can simplify 450 over 180. That's going to simplify to 5 pi over 2 radians. converting the other way, from radians to degrees, you need to multiply by 180 over pi. So this time we're bringing in the 180 and canceling out the pi. Okay, in this case, the pi's are going to cancel, pi over pi. And 8 times 180 is 1,440 degrees. Go ahead and pause the video and try the next one. So 4.3 times 180 over pi. There is not a pi to cancel this time. So the denominator is going to be pi. And 4.3 times 180 is 774. And this is in degrees. Finding the length of an arc. So arc length is abbreviated with S. R here is for radius. Theta is an angle measure, and it is in radians. So finding the length of an arc, what that means is if I've got 2 radii, I'm looking for the length from here around the circle to there. So for both of these, the radius is 8 inches. So the arc length equals r times theta, that's 8 times 3 pi over 16. So we're going to leave the pi out of the calculator, and we're just going to have pi in our answer. 8 times 3 divided by 16, we can simplify that to 3 over 2. So 3 pi over 2, and this is measured in inches. So the length of that arc is 3 pi over 2 inches. Go ahead and try the next one. Now you should notice that this one is in degrees, and it needs to be in radians. So here's how we're going to handle that. R is 8 times theta, which is the measure in radians, and that can be found by doing 127 times pi over 180. So this part right here converts that to radians for us. So 8 times 127 over 180 simplifies to 254 over 45, and our numerator still has pi in it. 254 over 45 pi, and that is measured in inches. And last, we are going to find an area of a sector. So again, a circle with 2 radii, and we're finding this area. 1/2 times the radius squared times theta. So the area is 1/2 times the radius squared, so that's 5 squared, times theta, which is 3 pi over 16. So the numerators are 1, 5 squared, and 3. 1 times 25 times 3 is 75 times pi. The denominators are 2 and 16, which is 32. 75 over 32 does not simplify, so this is our simplified answer. There's no units on this, so I'm just going to put U for units squared, because it is an area. It's got to be units squared. Go ahead and try the last one. So the area is 1/2 times the radius squared times the angle in radians, and this is in degrees. So 127 times pi over 180 to turn that into radians. So 1 times 10 squared times 127 over 2 times 180 is going to simplify to 635, and the numerator has a pi in it, over 18 units squared.